All right, recording uncertainties in measurements. So after this lesson, hopefully you will be able to record the absolute uncertainty for any measurement for any piece of equipment in the physics lab. Rules of uncertainties. We know the estimated digit is the digit you guess when you're measuring something. So it's always the last digit that you record when taking a measurement off a piece of equipment. As you saw with the little book experiment that we did, humans do a really good job of estimating a measurement by eyeballing the halfway mark. So the rule of thumb we use in science to list an uncertainty is this. We list half of the smallest increment on any piece of equipment. So for example, let's pretend we're talking about our meter stick. Our meter stick, we can estimate to the 100th spot. So we would list after our measurement the uncertainty value of plus or minus 0.05 centimeters. Here's some examples. Let's measure a slug. So the slug here, I'm going to measure him from his little antenna here, match it up here, to his little tail here. I chose a slug because we're in September and slugs are coming out. And I'm going to have a centimeter ruler, and centimeter ruler is really similar to our meter sticks. They go up by the 0.1 centimeter marks. That means that I can go to the 100th spot to record this measurement. If I look, it's going to be, I'm going to guess, 11.30 centimeters. That's how long I think this slug is. However, this measurement is incomplete until I record the correct uncertainty. So what I see here is, since it's going up by 0.1s, I divide that by 2 and I get 0.05 centimeters. And that's going to be my uncertainty. What? And so to list this at the very end, I can say to the reader that the slug is 11.30 centimeters long plus or minus 0.05 centimeters. That means that my measurement is in the range of 11.25 centimeters to 11.35 centimeters. And I know for certain my measurement is inside that range. So whenever I'm listing a measurement off a piece of equipment, I've got to add on there that uncertainty. So I know that the reader knows what range of uncertainty my measurement has. Let's look at another example. Here is graduated cylinder, 2 graduated cylinders actually, with 2 different volumes of water. So on this first one, I always read graduated cylinder from the bottom of the meniscus. Meniscus is the low point here. It has to do with hydrogen bonding in the water and the graduated cylinder being glass, but that's a chemistry thing. You'll get into it next year. So what I see here is that every mark goes up by 1, 2, 3, 4, 5. So I'm going up by 1 milliliter increments. So I'm going to estimate this. Since I'm going up by 1 milliliter, I can be estimating to the 0.1 spot. 1/10 of 1 is 0.1. I'm going to say this is 23.9 milliliters. Well, I'm going up by 1 milliliter increments. Divide that by 2. I get 0.5 milliliter increments. And so I'm going to say plus or minus 0.5 milliliters. Notice here that my estimated digit in my measurement is in the same place as my uncertainty in my measurement. My second graduated cylinder, this this one is going up by 0.1s. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. So since I'm going up by 0.1s here, I can estimate to the 0.01, 1/10 of 0.1 is 0.01. So I'll look and say, all right, 6.61 milliliters. Since I'm going up by 0.1s, 0.1 divided by 2 is 0.05, so it's just like our ruler, plus or minus 0.05 milliliters. So this is telling the reader on the first graduated cylinder that my range of volumes is between 23.4 to 24.4 milliliters. I know for a fact that my measurements lie in between these two values. Same goes with down here. I can say I go between 6.56 milliliters to 6.66. And I know for a fact that my measurement has to be between these values. So hopefully this quick little video helps summarize what we mean by uncertainties. Please go back to those lab stations that we've looked at last week and we're going to look at again. You're going to take those measurements again, but this time recording with the correct precision and with the correct uncertainties. Thank you.